Hello everyone, in this video I will show you how we can solve the example using this RSA algorithm. So in the given example, in an RSA system, the public key that is E, N is given. Of the user A is defined as 7119. So 7119 is the key pair is given. So we will consider it as E is equal to 7 and our value of N is equal to 119. After that, we have to calculate the value of phi of n, value of our private key that is D, and what is the ciphertext when you encrypt the message that is M is equal to 10. So here plaintext is given that is M is equal to 10 and we need to calculate our ciphertext with the help of the encryption process. So first of all, we will start with our first step of our example, that is we have to find the value of our P and Q, because in this example the value of n is given, and when n is given we will calculate the value of our two prime numbers. So 119 is the factor of 7 and 17. So we have to take the factor of these two prime numbers. So we are taking this prime number like 17 and 7. So you can also write 7 into 17, as well as you can also write 17 into 7. So I am taking this last number first and then I am writing here 7. So value of our P is equal to 17 and value of our Q is equal to 7. And there is one rule, that is P and Q should be factor of your n. So 17 and 7 is our factor of 119. Now the second step is we have to find the value of our phi of n. So phi of n is nothing but value of P minus 1 and Q minus 1. That is the multiplication of this P minus 1 into Q minus 1. So P minus 1 is nothing but 17 minus 1, and here we can write 7 minus 1. So the value will be 16 into 6 is equal to 96. So we will get here the value of phi of n is equal to 96. Now in the third step, we have to check the value of our public key. So the value of public key is already given in the example, that is value of E, and which is mentioned in that key pair, that is 7119. So 7 is the value of our public key. So we have to check that our E should not be factor of phi of n. So we are taking here 7 is not the factor of this 96. Okay. So now after that, this rule is applicable here. Now what rule we have to check? That is the GCD of E and phi of n is equal to 1. So I am writing here GCD of 7 and our 96 is equal to 1. So this rule is also applicable here. Now what we are checking? That is 1 less than E less than phi of n, means 1 less than 7 less than 96. This rule is also applicable here. So these three rules are applicable. So we are going with that fourth step, that is we have to find the value of our private key. So how we are finding the value of our private key? That is D. So our formula is D into E mod of phi of n. It should be equal to 1. So we are putting the value here D into value of E, that is 7 mod of 96 is equal to 1. So for this formula, we can calculate the value of D by using the method that is extended Euclidean algorithm. That is extended Euclidean algorithm. So how we can solve by using this extended Euclidean algorithm? So I am making first of all columns. and I'm putting the values like, first of all, that is quotient. Then we are taking the here values of A, then B, then here reminder, it is T1, it is T2, and it is T. So our value of A will be value of our phi of n, and value of our B is equal to value of our public key. So the value of our phi of n is 96 and value of our B is 7. Initially the value of T1 and T2 will be 0 and 1 respectively. Now we will solve this example using our extended Euclidean algorithm. So 96 divided by 7, we will get the answer, that is quotient as 13, remainder as 5. And once we are doing solving of our T, that is the formula is T1 minus T2 into quotient. So T1 is equal to 0 minus 1 into quotient. So quotient is 13. So I'm putting this value 0 minus 1 minus into 13 is equal to minus 1 into 13. 0 minus 1 into 13. So we will get the answer 0 minus 13. So we will get the answer minus 13. Now we have to shift the values. So after shifting the values, you will get here 7, it is 5, it is 1, then it is minus 13. So again we have to solve this for 7 divided by 5. So 7 divided by 5, our quotient is 1, our remainder is 2. And then again we are solving here the values like T1 minus T2. So T1 minus T2 is equal to 1 minus minus 13 into quotient. So quotient is 1. So we will get the values like 1 minus minus 13 into 1 is equal to here minus 13. So 1 plus 13, you will get the value, that is 14. So I am putting this value here 14. Now again we have to shift the value, that is 5. Here it is 2. It is minus 13 and it is 14. So 5 divided by 2, we will get the value quotient as 2, remainder as 1. And T is equal to T1 minus T2 into quotient. So I am putting here values, that is minus 13 minus 14 into our quotient, that is 2. So after calculating this one, we will get the value, that is minus 41. So I am putting here value minus 41. Again we have to shift the value, that is 2, then it is 1, it is 14, and this is our minus 41. So 2 divided by 1, we will get the value, that is 2 as a quotient, 0 as a remainder. And our T is equal to, our value will be 14 minus minus 41 into our quotient, that is 2. And we will get the value, that is 96. So I am putting here value 96. Again we are shifting 1, then 0, then here it is minus 14 and here it is 96. So we will stop here because we got here the value, that is 0, and after that we will not perform this step again. So here we got the value of our private key. So how we are calculating the value of our private key? So there are some rules. If the value of our T1 is positive, then we will take the value of D is equal to T1. But else, if T1 is negative, then what we are doing? We are doing D is equal to T1 plus T2. So in this case, value of our T1 is equal to minus 41 plus 96, and we will get the value is equal to 55. So here the value of our private key we got, that is private key is equal to D is equal to 55. So after that, what we have to calculate? We have to calculate our ciphertext based on the plaintext messages given. But before that, you have to put that value into our formula that we have written previously. So you can write down all the steps when the example will be given in the exam. So D into E mod of phi of n is equal to 1. So what is the value of D? We got here 55. Then value of our E, that is given 7. Then mod of phi of n. So phi of n, we got the value, that is 96. So I am putting here 96 is equal to 1. This formula is correct after putting the value 55 here. So the value of our private key is correct. Okay. After calculation of this mod, you got answer here 1. So 1 is equal to 1. It is true. Now we will perform the encryption. So the formula for encryption is ciphertext is equal to T raised to E mod of n. So the plain text is given in the example, that is m is equal to 10. So we are putting here the value, that is 10 raised to 7 mod of 119. So how we can solve this example now? 10 raised to 1 mod of 119. So 10 raised to 1 mod of 119 is nothing but 10. Then we can calculate here 10 raised to 2 mod of 119 is equal to 10 raised to 1 into 10 raised to 1 mod of 119. So we will get the value 10 into 10 mod of 119, and we can write it here 100 into 100 mod 119. So the answer will be 100, or if we calculate 100 minus 119, then we will get the value minus 19. So I can write these two answers here, 100 and minus 19. Now I have to calculate 10 raised to 4 mod of 119. So 10 raised to 4 is nothing but 10 raised to 2 into 10 raised to 2 mod of 119. So we will get the value, that is 10 raised to 2 is nothing but minus 19. Here it is minus 19 mod of 119. And we will get the value like 361 mod of 119. So we will get the value, that is 4. After that, what we are calculating? We have to calculate the value for our 10 raised to 7 mod of 119. Okay, so how we are calculating the value of our 10 raised to 7 mod of 119? We can put here value 10 raised to 7 mod of 119 is equal to 10 raised to 4 into 10 raised to 2 into 10 raised to 1 mod of 119. So after putting the values, you will get the answer like 4 into 100 into 10 mod of 119. And after putting the values into formula, into calculator, you will get the answer, that is 73. So 73 is the value for our ciphertext. So in this way, we can calculate the value of our ciphertext. So in the given example, the key value pair is given, that is 7 and 119. Based on that, we have calculated the value of our P and Q, value of our phi of n, value of our public key is given. Based on that, we have calculated the value of our private key using extended Euclidean algorithm. And after that, we have performed the encryption, and based on the encryption, we have calculated the value of our ciphertext.